Hey guys, second to last coding video for this intro course. So welcome to Python Computational Biology. We're finishing up, so we're going to do translation now. So the last time we did transcription, now we're taking the RNA, we're going to translate it into an amino acid sequence that gets folded into a protein, right? So very similar strategy, I guess. So let me pull up, where's my notepad. So we're going to do the same thing. Hey guys, welcome back to Computational Biology with Python. After a bit of a hiatus because my computer decided to die, I'm back. We're going to finish this introductory Python course here. So we have 3 lessons left in the introductory course besides the final project, which the video is already up for. We have 3 tasks. So let me switch to this right away, I guess. So we have, make it so you can see, there we go. There we go. As you can see, we have a transcription Python code we're going to do, a translation, and then this coronavirus genomics Python course. So I don't know if we put we did not yet. So just click on any access point to get to the Jupyter environments. So let's open this up. Oh, this shouldn't say final project. A lot of my stuff is, I'm all over the place because call this transcription. There we go. All right, good enough. Yeah, I'm a bit all disheveled because, like I said, I had to essentially rebuild my computer this week because it just decided to die. So we're working from behind here. Okay, so at this point we want to, let's do a new, okay. We want to build a Python script for transcription. So if you remember, for genetics, transcription is the act of taking DNA and turning it into RNA or messenger RNA, which then goes on for translation, which is the next section we're going to do. And translation, at that point, it becomes a protein. So remember, DNA is your blueprint. RNA is the message that goes from your blueprint to the protein, which is, the protein is what actually does the work in the cell, right? So it has function. DNA, for the most part, doesn't have function. It just encodes things that do have function. Both RNA and proteins can have functions. We won't get into the nuances of all that. So let's think of this from a scripting standpoint, though. So I'm going to, I don't think there's any way in Notepad to make your script bigger. Okay, let's do, I don't even know if I have this installed yet. Nope. If I get to that, I had to rebuild everything. Okay, we're going back to Notepad. Oh man, okay. Let's see. This is a mess already. All right, so what do we want to do in terms of this script? So I guess the first thing that we would want to do is prompt. I guess, all right, before I get too far into it, let's talk about what we're doing and what we have done. Okay, so in the beginning of this course, we kind of learned, all right, all these different techniques. We learned loops, we learned command line, we learned loading files, we learned printing things, we learned yada yada yada. We learned all these tools, but now we're going to think of it in these last 3 sections as making a product, right? Not to be confused with the data products class that we did, but making a script that a user could use or that you could use, right? So we want to define these things that we need our script to do. So we have like an outline, right, for our coding. So the first thing I think we would do is prompt the user to enter the name of a file. Generally, it's a FASTA file or FASTA file that are the nucleotide sequence for a gene to be transcribed into RNA. So the first thing we're going to do is prompt the user, right? So we say, okay, give us your DNA file, and we'll turn it into an RNA sequence. And the second thing we would do is translate. Read in the file, and then translate the RNA or the DNA into RNA. I think then 4 and 5 could be, you could reverse it if you want. It's up to you. So first I would say prompt the user to save the new file, the output, which is the RNA output. And then 5, you could say print the RNA sequence. Like I said, 4 and 5 can be switched. You could have it printed and then prompt the user, or you can prompt the user then print it. Doesn't really matter. But this is our outline, right? So prompt the user to enter the name of the file to be transcribed into RNA. Read the file that they gave us the name for. Translate that DNA into RNA. And if you remember, we need to switch thymine to uracil, or U. That's our big biology aspect here, right, that differentiates RNA from DNA. Prompt the user to save that new file and print. The reason we're doing this is so we can use this file for the translation. Well, you get it. Script. There's no J in translation, but okay. Because we'll use it in the next one, so you don't have to go download them. Okay. So that is our outline. That's generally kind of a good way to like design a code, right? To outline what you want it to do, what steps you need to take to get to the endpoint. Okay, the next thing, we need to get a FASTA file. So what we're going to do is I'm going to Google search NCBI and go to this NCBI National Library of Medicine. On this drop-down menu, I'm going to hit gene, and I am going to name any gene you want. If you're in a 400 level class, I'd hope you can name one gene that exists. I'll name SUMO, which is a gene that I worked on as a graduate student. It's a small ubiquitin-like modifier, and it's kind of like ubiquitin, but it does the opposite thing. So ubiquitin tags proteins to be degraded. SUMO takes proteins to not be degraded. At least in rice it did. It might have, I haven't worked on it in 15 years at this point, so it might have other functions as well. Okay, so I just picked this one from a Drosophila melanogaster, which is a fruit fly. Now, you probably have this gene viewer and all this stuff on your page here. As you can see, I'll scroll down over my picture so you can see here's the gene viewer. Now, up above this gene viewer right here, it says FASTA or FASTA. We click on that, and you should get this nucleotide sequence. You can see SUMO's a smaller gene relatively. Now, up here, you should have send to, and we're going to send it to, we're going to pick only the coding region, because if you're doing RNA, you only want the coding region. And we're going to say FASTA nucleotide. We're going to create file. And now what you can't see is behind my picture, where's my mouse? There we go. Behind my picture, it saves the file over here, right? So it's on my desktop. It's not on the cloud or anywhere. Okay, so now we're gonna go back to Praxis. You can close out of NCBI. You're gonna open up your Jupyter Labs like this. Go to Desktop, Classroom, My Files. So you're in your own personal files. And then up here, there's an up arrow. It says Upload. And you're gonna pick that file. So I think it was sequence 1. I'm hoping. I'm sure it is. But when you download it, you can change the name of it too before you upload it. So now it should be in My Files. Like yours doesn't look as cluttered as mine, but it's there. Okay, so now we have our sequence that we're going to prompt. I'm actually going to find mine. I'm going to change the name of it so I don't have to give it sequence 1. I can give it, I'm right clicking on it, rename, and I'm just going to call it sumo. But like I said, pick whatever gene you want. Heat shock protein, BRCA1, BRCA2, whatever. Whatever your head can imagine. Okay, so now let's write a code. Okay, so I'm going to save as, and I'm going to call this transcription. Save. Okay, so let's get rolling. Overwrite, because I already tested my file. All right, so first thing, I'm going to annotate. So this is one thing that we haven't really been doing a lot in this, but as you start writing programs, it's really important to do this, to annotate, right? And that means make your code readable to other people. So if you took my R classes, I like hammered it more than this class, and I should have hammered it more, but better late than never. All right, so I'm going to say prompt user to enter the input FASTA file name. And so since I put that hashtag there, remember that like makes it so it's not executable code, it's just comments. And so I'm gonna put input file name equals input, enter the name of the input FASTA file, and then close that. And I'll run this chunk. And so see, the user now inputs the name of the FASTA file. I renamed mine, but it was sumo.txt, I believe. I want to make sure it wasn't dot. You can name them .txt or you can name them .fasta. It's just a text file regardless. Okay, so that's good. So now open the input FASTA file and read the DNA sequence. That was our second step, right? And I'm going to say with open input file name R as input file DNA sequence equals nothing. So I'm saying, okay, take the file name as the input file, then create a variable called DNA sequence what has nothing in it. Then I'm going to say for line in the input file, so for each line, if line starts with a, there we go, greater than, less than, or a greater than symbol, continue. So all that's saying is, if you remember, let's find my FASTA file I downloaded, download sequence 1. So if you look at these, I have 2 sequences here. Well, this is going to be interesting. This might transcribe to, what's going on with that? I might have to use Ubiquitin. I don't know why that one has 2. So if you look at this, this FASTA file, the first line, this just has information about the gene, right? So this has its location, what the gene reference is called, what the protein is, all this different stuff. And then the actual nucleotide sequence follows that. So we're saying in our Python script, we don't want to try to turn that into to RNA. That doesn't make sense because it's going to throw errors because we have 4 nucleotides in DNA. And if all these other symbols in that more than the alphabet, right? So we're saying, okay, if the line starts with this symbol, then just ignore it and go to the next line. Okay, and then we're going to say DNA sequence plus equals line strip. And what that does is takes one letter at a time from that that sequence or that line and breaks it apart into each character being its own chunk, right? So we're going to run that. Then we're going to say transcribe the DNA to RNA. So we've stripped that first line that has the greater than, less than symbols on it. We've created a empty variable and then said, okay, for each thing, each letter in this sequence, put it as its own line or its own thing in DNA sequence. So then we're going to say RNA sequence equals, and we're going to create an empty vector for that. And then we're going to say for each nucleotide in our DNA sequence, spell it right, if the nucleotide is equal to T, then RNA sequence gets a U added to it, right? Because remember, thymine is turned to uracil in RNA sequences. So we're saying, all right, read each letter of the nucleotides in our DNA sequence where we stripped apart this DNA sequence. And we say, if it's a T, then add a U. Else, if it's not a T, just add whatever letter it is. Nucleotide. So the only thing we need to convert for transcription is T's to U's, right? So we run that. Great, gravy. And now prompt the user to enter the output file name. You can do this second to last or last. Output file name equals input, enter the name of the output file. So people can save it for whatever they want. So we'll say, I'm going to do, I already did, so I'm going to do ubiquitin, because I don't know why my last file name had, my sumos had two of those sequences together. And then we're going to do save the RNA sequence to a text file. So now we actually do the saving after we got the name. So with open output file name w as output file dot write. Now we're going to write the RNA sequence, and then print the RNA sequence has been saved to, and then we're going to do these curly brackets, output file name. So that's just going to, what that curly bracket does is it takes whatever our input was from before, and it's going to print that out there. So now we can run this. Output file name. Why is that not defined? Okay, I found some errors. So I was having this error down here where I was saying stuff about output file name. It's because this section right here, I had out file name instead of output file name. So I changed this code. Let's just run everything from the beginning here. So input file name ubiquitin .txt. Enter. Next chunk run. Next chunk run. Next chunk run, where I fix this to say output file name instead of out file name. And we're going to say ubiquitin rna.txt because we're going to save it for our next code chunks. Now this should work. There we go. So although it didn't take it as it didn't print it, and that might be a product of doing this in the notebooks here, but whatever. And then I can print our RNA sequence. So you can see here now everything, all the U's have been added instead of T's, and we're good to go. So I'm going to save this. As you see, not a lot of code, but let's go through our checklist here, right? So we'll put it right up here. Prompt the user to name a FASTA file. We got that right at the beginning here. Read the DNA file. We do read the DNA sequence in right here. Translate the DNA to RNA. So we transcribe, or this should say transcribe, but we are transcribing it from here by replacing T's to U's, but keeping all the other nucleotides. Prompt the user to save the new file. We have that right here. And then print the RNA sequence, which we have right here. So that is it. Save changes, not to my text file, but I do want to save changes to this. Make sure you save this for your final project. So that is it. So it's not terribly difficult. It's nice to map it out ahead of time if you were going to do this from scratch to kind of give an idea of what you need to do in terms of writing the code if you want to like hit all your benchmarks throughout. So with that, thank you for watching. I appreciate it. I hope you learned something. In the next video, we will do now translation of the RNA into protein. So you'll have your saved RNA TXT file, text file that we will now transcribe into amino acid protein sequence. So thanks for watching. If you're watching on YouTube, hit like, hit subscribe, and I will catch you in the next video.